Welcome to Kyiv Polytechnic Institute, to the Chair of Machine Dynamics and Strengths of Material. My name is Yeschenko, I'm a PhD of this department. This is Mariana, she will be PhD very soon, and we welcome you to the biomechanics laboratory. So, welcome. And some objects of our work in this biomechanics laboratory. And here you can see our students and our professor, Shidlovsky, who is the man in charge of the laboratory. He's also a professor, very good professor. He's doing biomechanics for more than 15 years. And yes, let's go in. So welcome to the biomechanics laboratory. This is our laboratory and also the place where students take their lectures and practices on material science and of course the biomechanics. Here you can see on the walls some of the publications and some of the information about mechanical properties of biological origins and some publications related to biomechanics that were done during last 10-15 years. And of course this is a scientific laboratory, and here we have different testing machines and some very interesting equipment, measuring equipment here. And okay, this is the table of our professor who is in charge of this laboratory. And this year we have students from Vishwaniketan, from India, that are joining us and doing some projects on biomechanics. Alright, and this year, each year we have actually different objects to study. This year we have studied the talus bone and metacarpal bone. So, and I think the students Ashwin and Akshay should tell us about what they have learned and what are they doing now. Okay.
Hello, I am Akshay Jorwekar. Basically we are working on talus bone. As I said, we are right now working on talus bone, which is actually located near the ankle of a human being. Right now we just picked up those MRI scans, imported this in Katia, and now we are working in space plane. From here we are now going to analyze the entire fracture. Now when you see this layer, this is the fracture where we are going to study, and we are going to get few conclusions after this. And this is the entire thing in the project.
Okay, and what the fixation system you use?
Right now we have total 8 specimens which are under investigation. There are total out of those 8 specimens we have 2 screws and 1 screw and 1 Kirschner rod. These are the combinations in fixation systems, and they are being placed in various directions, in different directions and positions. Now this will be compared, and accordingly we will get those analysis, and then we will at the end conclude which fixation is better and superior, and this is actually more helpful for those doctors to investigate, especially those surgeons, at the end to conclude which fixation is better.
Alright, and now let's move on to the second project for Metacarpal Bone, and Ashwin should present his work.
Good afternoon all. My name is Ashwin Daware and I am working with Professor Victor here. My role is in biomechanics is on metacarpal bone. Metacarpal bone is located here in hand. So we are actually investigating the hand bone of the finger, index finger. So here you can see this is the first model that we have made. So there are 3 different models that have been made in SolidWorks.
What are the differences?
Yes, there are actually 2 types of fractures that mainly occurs. So one is the middle fracture and one is at the head. So for middle fracture we have external fixation system. So there are two types of external fixation system. One is with plate and one is without plate. So this is the first system. This is middle fracture and this is the second system. And one more is there which is the fracture at the head, which is internal fixation system with plate. So actually doctors don't know how to actually analyze the actual stresses that are produced. So in order to know which fixation system, like how much load, like which fixation system to be used, mechanical engineers, they are helping them to find out the exact actual forces that are applied, and so that they can select the appropriate fixation system. So here the computer tomography image was imported in SolidWorks, and the 3D model of metacarpal bone was created, and then three different fixation systems we made. And right now we are also done with analysis of two different models, and one model is remaining. The analysis, simulation analysis was done in ANSYS 18.1. Here you can see the analysis. These are the stress on sponge bone. This is the total deformation here. The different stresses on cortical bone, you can see.
So we have some concentrators.
Yes, we have some stress concentrators here.
So we need to analyze this and
Yes.
say whether
Yes.
the loading conditions are appropriate for this kind of.
And yes, and also directional deformation. Actually, we are going to compare the we are going to compare our study with the students which are doing experimental studies. So here we will compare the different deformations in different directions as they have done in experiments. So those directions will be taken in simulation, so that we can have the as closest as possible with appropriate results. So finally, once we are done with all simulations, we are remaining with only one. So once we will finish this, we will compare both the experimental results. Already we have experimental results with other two guys, and we will compare these results with our results, and we will find the percentage errors, and thus we will say this fixation system is the best for the in all three. Thank you.
So now we come to the experimental section. This is our universal experimental machine and some biomechanic objects. This year, Kyiv Polytechnic Institute, Igor Sikorsky, come two students of India and Zaid and Mudit, and they explain you about our objects.
Hello, so my name is Mudit Golecha. I have worked on the talus bone. I have done the experimental part for the talus bone. So we found we've used different screwing fixation systems to fix the fracture of the talus bone. We found out the force and load from the machine by doing the experiments. So we've done 8 experiments for the 8 talus specimens. We found the best specimen for the screwing fixation system.
Hello guys, I am Zaid. I've come here for my musical lesson, and I'm working on metacarpal bone. You can see this is the metacarpal bone, and this is located here on your hand. This is for the index bone. We have different kind of fractures here. You can see this is the external fracture system. This is the overhead fracture system. This is the system which has been fractured from middle part. These are the different types of fractures, and we have been working on it on the test machines. We are applying different types of load to see where the bone deforms. We have got different readings. We have got the deflections from this machine, and then we have converted this deflections into the graphs, and we have got different readings, and we have made which kind of system we can assure that the different fracture systems can be good for different types of loading. We have done different loading such as bending, rotation and compression. So this was from the experimental analysis laboratory. Thank you.
So this is our second year of this UG fellowship program. Currently we're almost finished on our projects. The boys are doing very good. We hope to have good results. Also, if we will be good, we also will be able to publish some papers at the end of this program. And I hope in the future this program will have like more impact to the society, and maybe these biomechanical projects also will help students from India to make their master's programs, PhDs, and help them in their lives. So, thank you.
Очень рада была участвовать в этом проекте.
So it was a pleasure to be in this project.
И студенты очень меня порадовали, они очень умные, заинтересованные, вот, проявили работоспособность. В общем, хвалим.
Students that came to our laboratory are very good students. They showed a big amount of interest, and they worked very hard actually with us during this program.
Очень надеюсь, что они будут к нам приезжать еще в КПИ на другие проекты, ну вообще и на биомеханику в том числе.
In general, we hope that maybe next year these students can come to Igor Sikorsky Polytechnic Institute again, maybe on some other projects as well.
Вот, спасибо большое университету Индии за отличных студентов.
Big thanks to the Yeschenko University for such great students.
Ну и на этом все. До следующего года.
That's all for now, and see you next year.